Hey everyone, welcome back. Today we are going to talk about perceptual organization. So, we have spent a little bit of time talking about sensation and perception. We've discussed specific sensations. Then we've talked about how perceptions are the result of those sensations working from the bottom up and what we call top down processing, which is how we think about or organize information. So, that's going to be a big aspect of today's lesson is how we organize the information that is sent to our brain from our different senses. So, we're going to start by talking about a group of psychologists that formed in the early 1900s, started by this guy named Max Wertheimer. And they formed what we call Gestalt psychologists. Now, Gestalt psychology is really interesting. The word Gestalt means whole. It's a German word that translates roughly to mean whole, not like a hole in the ground, but whole with a W, complete. And what Gestalt psychology is all about is this idea that as we form perceptions, we need to recognize that often the whole is greater than the sum of its parts. I want you to think about that phrase for a moment. The whole is greater than the sum of its parts. So look at these images I have on the screen. If we look at any individual image by itself, then maybe over here we see little blue Pac-Man characters and little triangles and things like that. Those are the individual pieces, but that's not how we perceive it. The end perception is greater than the sum of its parts. The end perception is a cube, right? We likely perceive a cube here on the left that's kind of sitting on these other circles, these blue circles that are complete, even though that's not technically what we sense. On the right hand side of your screen, you likely perceive a Dalmatian, right? You perceive this dog, even though that doesn't exist on the screen. What you sense is a bunch of black spots all over the screen, but your brain organizes all those little pieces, individual pieces, together and creates a gestalt. It creates a whole. It completes the perception. The whole is greater than the sum of its parts. So rather than seeing these bits and pieces of information, your brain tries to complete the puzzle. And so there are all of these different types of gestalt principles. And I have a bunch of them listed here for you. I have a similar handout that I've uploaded to our class page that talks about some of these different Gestalt principles. And I don't want to spend too much time because we could spend a lot of time talking about them. But if you pause these Gestalt principles and you kind of take a look at this slide or you look at the handout that I put on our website, they kind of make sense. The idea is our brain is trying to organize sensory information, and how we organize sensory information depends on a number of different factors. For example, the Gestalt principle of closure. We want to fill in the gaps. So if we get this incomplete information, like you see this kind of incomplete square or circle or triangle, your brain completes the perception. You likely have no issue at all seeing a square, circle, and triangle, even though those sensations do not exist. The perception does, the sensation does not. So it's the Gestalt principle of closure. Sometimes we organize information based on whether or not it is similar to surrounding information or if it's physically close to surrounding information. And so that's demonstrated with Gestalt principles of similarity and proximity. Continuity is a really interesting one. I'm going to kind of move my face here off the screen. So if we look at this image on the screen, it has these two lines. Likely, when you look at this image that I'm circling with the mouse, you likely perceive it as one straight line and then one curvy line that intersects. So you perceive it as we see on the left, even though technically it could be perceived as what is on the right. We likely don't perceive it that way because the law of continuity is this idea that our mind will follow a continual path to kind of create this perception. Simplicity, if you see stimuli, your brain is going to try to find the most simplistic perception that it can. And so when you look at this kind of ambiguous stimuli, you might perceive it as a white wooden picket fence, or maybe you perceive it as these kind of black martini glasses. And then on the right hand side, the idea of figure ground. Figure ground is this really interesting perception where we are trying to perceive an object from its surroundings. So if you're looking at your desk and you're looking at your notebook sitting on your desk, you can perceive the difference between your notebook and the desk itself. The notebook being the object, or what we call the figure, and the desk being the surroundings, or what we call the ground. And so sometimes we can play with kind of figure ground and create some cool perceptions. It might be hard to see with this video, but over my shoulder here, there's this MC Escher poster hanging up in my wall that plays with figure and ground. And if you're looking at what's in black, you kind of see these demon bat creatures. But if you're looking at what is in white, you see these more kind of angel looking figures. And so it plays with the figure ground perception of what is the object and what is the surrounding. So another way that we organize information when it comes to our brain is this cool thing called the phi phenomenon. And you've maybe seen this around the holidays with different holiday lights, or if you've ever been to Las Vegas and you've seen the Strip, or maybe if you're driving through a construction zone, you've seen this. The phi phenomenon is when we perceive movement even if it doesn't exist. So for example, if we take a string of lights and we blink one light at a time down the string of lights, well, what we are sensing are just lights turning on and off. But if they happen in this pattern, our brain will perceive movement. It'll look as if the light is traveling down the string of lights, or that construction sign will look like an arrow kind of pushing you toward the side. You perceive movement even if movement is not there. This is how movies used to work, where we would take still images and then we would move them quickly, one image after the next. And when you're looking at these images presented one after the other, you see still images. Your brain puts them together and creates movement. It's this idea of the phi phenomenon. Now, we also have constancies with perception, what we call perceptual constancies. And we're going to talk about three of them. So we have what's called size constancy, color constancy, and shape constancy. What do they all have in common? Well, the idea behind perceptual constancy is this. If an object changes, or in other words, if the sensation changes, our perception often remains constant. Think about that. If the sensation changes, our perception remains constant. So size constancy, for example. I have this pen here. And right now, when you look at this pen, it's kind of hard to see on the camera, okay? While you look at this pen, it is being projected on the retina in your eye, and it's taking up a certain amount of space in the retina. And then if I hold the pen right here, right, it takes up a lot more room on your retina. But I doubt that you believe that the pen has grown to being this giant monster pen just because it's taking up more room on the retina. The sensation has changed, but your perception is constant. It's just closer or further away. You've got the picture of this guy holding the apple. No one perceives this as being a giant apple the same size as the guy's head. But if we're looking at what is actually happening, the sensation, if we're thinking about the space on the retina, well, the apple is taking up just as much space on your retina as this guy's head is, but you simply perceive the apple as being closer. So that's the idea of size constancy. It's a type of perceptual constancy. Color constancy. As we have more and less light being reflected off of colors, well, what is actually hitting the retina changes. If you are in a very dim room and there's not a lot of light present, then the sensation is fairly dull colors. But you don't believe that there are actual dull colors in the world. So if we're in my classroom and I'm showing you something and I hit the lights, and all of a sudden everything kind of turns into this kind of dullish color, you don't think that it's magically changed. You still think, for example, that my red stool in the room is just as bright red as it always is. Even though the sensation has changed, the perception has remained constant. And then finally, shape constancy. Grab my coffee mug. I like to use this as an example, right? So shape constancy. If you look at the top of my mug right now, your brain may tell you that it's a circle, even though that's not what you're actually sensing. It is what you're perceiving. Right now, if you look at my mug, what you sense is an oval. you're not sensing a circle. In order to sense a circle, you'd have to look straight into the mug, right? To actually sense the circle, it'd have to line it up with the camera there. That's the only way that you're sensing a circle. Instead, when I hold it at an angle, what you sense is an oval, but you perceive it as a circle because of shape constancy. Even though the sensation changes, you perceive it to be the same. Just like this door in the picture on the slide here. As the door opens, the actual shape that is being projected on your retina changes, but the perception remains constant. So that's what we call shape constancy. Now, if we go to our next slide here. We can't talk about perceptual organization without talking about depth and depth perception. And so the last handful of slides will all deal with depth perception. And we experience depth perception in a number of different ways. We can categorize the way that we perceive depth in two main ways. Some of the ways we perceive depth are what we call binocular cues, and it requires both eyes to perceive depth. But we also use a lot of monocular cues to perceive depth. And so we're going to go into detail about both binocular and monocular cues. So let's start with binocular cues. There are two different types. Binocular cues, again, both eyes to help us perceive depth. Well, one binocular cue is what we call convergence. You have two eyes that converge onto an object. And so if that object is very far away, that angle of your eyes coming together, if I'm looking at the wall at the end of my classroom, it's not a very, significant angle as they're coming together toward that wall. But as an object gets closer and closer and closer to me, my eyes have to kind of come crossed, right, as they converge at this object that comes closer. And so as the eyes converge, it sends a message to my brain with how close that object is. You can see kind of this image here is supposed to be essentially a bird's eye view with your left eye and your right eye. And then here's an object that you were looking at. If the object is very far away, you can see how that angle is different than if that object is very close. And that angle is sent to your mind and can be interpreted as distance. The second binocular cue is what we call retinal disparity. And retinal disparity is this idea that your left eye and your right eye see a slightly different picture of the world. Of course they do. They're different eyes. So if you close your right eye, you get one image of the world. And if you close your left eye, you get a slightly different angle of the world. We put these two different angles together in our mind, and it creates a 3D image. That's the idea of retinal disparity. It's how 3D movies work. 3D movies will send one image to your left eye and a slightly different image to your right eye. How do they do it? Well, they film a movie with two cameras that are right next to each other. And then they have the film from this camera be forced into one eye and the film from the second camera be forced into the other eye. And they can do that through, polarized glasses and having a certain filter over those images. It's pretty cool, and it creates this 3D image. So retinal disparity, your left eye and your right eye see a slightly different image. You put them together to create 3D, which gives us the perception of depth. Now, seeing in 3D and perceiving depth are not the same thing. 3D allows us to perceive depth, but we can perceive depth in something that's not 3D. It happens all the time. If you look at a photograph, right? You can perceive depth. You can perceive that things are closer or further from you, even if they aren't in 3D. As you're watching this lecture, I'm not in 3D, right? I didn't film this in fancy 3D, but you can still perceive depth. You can tell, for example, that I am closer to the screen than the file cabinet behind me. That's depth, your ability to detect what's close and what's far. And there's a number of different ways that we can do this. So let's go through what we call monocular cues. If you look at this image, how can you tell, for example, that this guy with the spear is closer to you than perhaps this elephant? Think about it. There's a lot of different ways that you can detect that man is closer to you than the elephant is. One way is through what we call relative size. Not to be confused with size constancy. Size constancy is an object gets further and further and closer to you, the size remains constant. Relative size is this idea that we've got an idea of how big something should be. And so if it is close or if it is far, relatively speaking to other objects, it will let us know if it's next to us or if it's further away. I think I worded that really confusing to you, and I apologize. If you have two objects that we are familiar with their size, one is large and one is small, then we know that I apologize for the interruption. If we have two objects that we are familiar with their size, and one object appears to be much larger than the other, then we would assume that the object that is much larger is closer to us than further away. That's the idea of relative size. And I've probably completely confused you as I've stumbled over my words, so let me explain it this way. If we walk out in the hallway and I see a student walk down the hall, well, they will cast a smaller and smaller retinal image, but I don't think they are shrinking. That's the idea of size constancy. But if I walk out in the hallway and I see a student 5 feet away from me, and I see another student 100 feet away from me, the student who's 5 feet away from me will appear much larger. I don't think they're any larger, I just know they are closer to me. That's the idea of relative size. Ooh, I hope that makes sense. That's a little confusing. If we look at these monsters, right? This first image, you probably think this monster is much bigger than the monster in front of him. He's not. Those two monsters are the exact same size. If we take the background out, you can see they are in fact the same size. You can pause the screen, you can measure it with a ruler. But relative size is playing tricks on our brain, telling us, oh, it must be closer because it has this perception of being much, much larger. All right. How else can we tell if things are close or far away? Well, if it overlaps, I told you that you can tell that I am closer to you than the cabinet. Why? Because I'm covering up the cabinet. If you have two objects that are supposed to be the same size, like two playing cards, you can tell that the king of clubs is closer to you than the king of spades because it's covering up. It's not hard. The only thing that's hard is remembering what it's called. It's called interposition. Interposition, think overlap. You know that my right hand is closer to you than my left hand for no other reason than my right hand is covering up my left hand. We lose texture as things get further away. I don't know where you're sitting right now, but if you look at the floor right below you, whether that's carpet or hardwood or whatever, you can see very specific detail. Then if you look at the floor as far away as you can see, wherever it is you're sitting, it's likely less detailed. It becomes smoother in our vision. That's the idea of texture. This class is not asking you what the definition of texture is. That's ridiculous. This is simply trying to tell you that we use texture as a monocular cue for depth. Linear perspective and relative clarity. Again, these are monocular cues. You only need one eye to do this. With one eye closed, I can still see what is near and far in this picture. Linear perspective is the idea when parallel lines converge. And so these parallel railroad tracks converge to a point as they get further away. I know that that part of the railroad is further from me than down here because they have converged into the distance, into a focal point, what we call linear perspective. Relative clarity. As things are close to us, they're fairly clear. As things get further away, they become more hazy and less in focus. That's the idea of relative clarity. And finally, the last one is what we call relative height. Relative height is this idea that as we look around our world, more often than not, if things are higher up in our field of vision, they are further away. If things are closer to us, then they are lower in our field of vision. And so with one eye closed, I can look at this picture of Pirates of the Caribbean, and I know that this ship in Johnny Depp is closer to me than this ship back here. Why do I know that? Relative height. Because when things are close, they are lower in our field of vision. As things are further away, they are higher up in our field of vision. All right. Lots of different monocular cues. We talked about some binocular cues, and we talked about some other ways that we organize perceptions. Lots of terms in here and lots of things that can get confusing and overlap. I went pretty quick. If you have questions, you got to email me. Make sure you have examples in your notes. Examples are key. Don't just get those definitions. Give examples because you know that's how we ask questions in this class, making sure that you can apply the terms. I hope that's helpful. If you need anything, let me know. And as always, everyone, best of luck. I got to figure out how to turn this thing off. There we go. Bye.